So we have now seen how to deal with normal forces, right? Let us now look at a couple of questions where we deal with tension forces. But what I'm going to do is, instead of just telling you tension forces for one block, we will have connected objects. So objects that are connected by a rope, and then when you're pulling one object, then you're looking at forces between the two, that is tension forces in the rope connecting these two blocks. So let us actually solve a problem to understand how to deal with such cases. Let us now look at the case where I have a block that is resting on a floor, and let us say it is connected to another block. Okay, so there are two blocks, and I am pulling it on this side with a force of, let us say, 20 newtons. Okay, and let us also say that this particular block has a mass of 3 kg and that block has a mass of 5 kg. And there's no friction to worry about right now. Okay, now you know that it's going to accelerate like this. But what I want is, what is the tension in this rope? How do we do this? We draw the free body diagram. Now this free body diagram, I will keep using this term and this idea a lot. Free body diagram basically means take this body and place it here. No floor to worry about. There are going to be vertical forces which I won't draw now just to not confuse. We'll assume that everything is only horizontal. Okay, but in general, free body, you must draw vertical, you must draw horizontal. You must mark all forces on the diagram, on that block. 3 kg, but you should not mark acceleration on the body. You should mark acceleration outside. Okay, now let us take this fellow. This one has a 20 Newton force. Is this force also 20 Newton? No. That's a very common mistake. People assume that if I pull this with 20, this is going to pull that with 20. It won't. This block will pull this block with T and that block. So this is the second free body diagram. So whenever we have blocks or objects connected, that's how we should solve the problem. We draw each object. This block is going to pull that block through this rope with a force T. Actually, this block is pulling the rope. The rope has tension, so the rope is pulling that block. It's actually 2-3 steps like that. 5 kg. There is also a 50 Newton force downwards, and there is a normal force, a different normal force. Here there is going to be a different normal force, 30 Newtons, but I don't want to draw that. This is one body, second body. Now, you know that, look at this diagram. Do you think this will move faster and that will go slower? Or will they move together? What do you feel? Well, 20 Newton, but then this and this are connected. So this cannot run away, which means this is moving with A, that is also moving with an acceleration A. We could have done like what we did earlier. We could have combined it together and said it is one big 8 kg block. And then we can say net force of 20, 8 kg block. But I don't want to do that. I'm going to look at it like this. Then I can say this fellow has an acceleration A, that fellow has an acceleration A. For this object, let us write mass into acceleration. Mass into acceleration. It must be the net force on this side. Notice, I am always writing MA first. Then I'll write net force. Mass into acceleration. Should I write T minus 20 or 20 minus T? I should write in this direction 20 minus T. Very good. So this is 20 minus T. Now let us take that fellow. That has a different mass. Same A. So 5A. But what is the net force on that object? There's only one force. So it is just T. There's no other force. There's no 20. This 20 does not act on the 5 kg block. Very common mistake. People assume if this force is acting on this, it is connected, it must act there. Sorry. This force is acting on that. So if, for example, there are two people standing, I push you, you push your friend, you are pushing your friend. You can come back and say, no, 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 it was me that I pushed finally. But that is what we call ultimate cause, right? But in physics, we will deal with, in that particular instant, what is the force acting on you, okay? So for example, in physics, basically, my argument is if I take a gun and shoot somebody, right? I will say, I did not kill that person because I pressed the trigger. Then the gun basically exerted a force on the bullet, not me, gun. Then the bullet went and hit him. So the bullet hit him. Therefore, go and arrest the bullet. Of course, no court is going to take that, right? Obviously, because who pressed the trigger was the culprit, right? So that person was the person responsible ultimately, but not in physics. In physics, why is this fellow moving? Not because of 20, but because of T. In physics, we will say 20 pulls 3. 3 pulls rope. Rope pulls 5 kg. Who pulls 5 kg? Rope pulls 5 kg, not the 20 newtons. You understand? It's part by part, piece by piece. But ultimately, of course, 20 is responsible. But I'm just saying that just to understand it, this is how we should think about it in physics. Okay. Now, if I add this up, I can solve. If I add this, I will get 20, TT cancels out. Always write the equations one below the other. You'll find it's easy. Add 20, add 80. So what is it? 20 by 8, 10 by 4, 5 by 2, 2.5. Remember, this is what we would have done before. We would have said, think of this as one big block, 20 by 8. Now, I didn't do that. But now, advantage is once I've got A, I can substitute for A here. 5 times 2.5. How much is 5 times 2.5? 5 into 2.5. So this is 12.5. So I know that this tension is 12.5 newtons. The question was, what is T? Answer is 12.5 newtons. So is that clear? So this is how we will go step by step to find out what is the tension. Now this was a very simple question with 2-3 blocks together. We could have also done this by saying together, let's first find out what is the acceleration by using this directly. Then using the acceleration, we could have found out what is the tension. But if I had 3 blocks, 4 blocks, different forces, this is the approach we must follow. Now, the second kind of case that we will need to deal with is when you have many blocks. Right now, I'll choose a case where it is one very simple case, okay? And then there is a pulley. And then there is this rope continues around the pulley, and therefore there is another block hanging. Now this is a frictionless surface, just to make life easy. Now what is this fellow pulley? Pulley is just a round object. There are some 2 kinds of pulleys that you can deal with. Sometimes it is just a round smooth surface and there is a rope. So there is no friction. So the tension here is the same as the tension there. This is just simply bending the rope. The second kind of pulley is where the pulley itself will turn. Like for example, sometimes in a well, you might have seen there is a small round thing. And when you pull the water up, the thing itself turns. Okay, so this could be something which is very light and very easy to turn. Or it could be a very smooth surface and this is just going over it. Both things we will call pulley. Okay, so we call this a pulley. The main idea to keep in mind, we are dealing with smooth pulleys or massless pulleys. They are not the same, but whether you deal with a smooth pulley or a massless pulley, what I am saying will be true. But if they were also going to deal with sometimes nice big fat pulley and a very rough pulley, well, if it's a rough pulley and a fat pulley, then unfortunately just to make it rotate, you will need to exert forces. The tensions will not be the same. Now, for smooth or massless pulley, if this place the tension is T, there the tension is T. We have already seen that for this place, if this tension is T, 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 T. Now this side and this side have the same tension because it's a smooth or a massless pulley. Once you know this tension is T, all these are T, T, T. That makes life easy. Let us take an example to solve this problem. So for example, if this was a 10 kg block, and let us say that this was a 6 kg block. What do? So first thing I'll do, draw the free body diagram. So zoom in here. Free body diagram is like a zoom in effect. So take it out. Let's put the block here. What is the mass of the block? 10 kg. Now there is a force. There I didn't worry because this block was not, it's only moving horizontally. I didn't have to worry about vertical. Whereas here, what is the vertical force? 100 newtons. Is there a normal force? No, there is no surface. This is hanging in air. Well, it's not hanging in air. Maybe there is a table. On the table there is this pulley. So that means this is the kind of diagram and this fellow is basically getting pulled down. But only force is 100. Is there any other force? T. Right? The rope is pulling. So there is a tension T. Now let us take that fellow 6 kg block. 6 kg block also has 60, but 60 is downwards, it's not this way. Right? So this is 60. I don't care. This is N. I am just going to ignore this. Why? Because I know that this block will move like this. Vertical forces will not affect horizontal motion. Horizontal forces will not affect vertical motion. This object has vertical motion. This object is going to have horizontal motion. So you know that perpendicular forces do not affect. So if you want something to move like this, or you want to have something to have an acceleration like this, you need a force like this. You want it to have acceleration like this, you need a force like that, vertical. Horizontal and vertical do not affect each other. Okay, but that means this fellow must have a horizontal force. Who is exerting the horizontal force? Rope. It is not the 10 kg exerting a force, it's the rope exerting the force. So the force is T. Now this guy has an acceleration A. This guy has an acceleration A. Same A? Yes, because if this fellow goes down by 2 meters and that only goes by 1 meter, rope will break. If this goes down by 1 meter and that comes like this, rope will have a slack. The length of this rope is fixed, no? So that means if this guy moves by A, this must also move by A. Is that clear? Think about it, it's a very important point. Okay, so if this is A, that is also A. Then I can write mass into acceleration must be net force in this direction. These two don't matter. What is the net force in that direction? T. And for this fellow, I can write mass into acceleration. Should I write T minus 100 or 100 minus T? I should write 100 minus T. If I combine this, you can see that 100, T cancels out, is 16A. And so from this, what can I say? A is equal to 100 by 16. We can do the calculation. You will get, if I cancel out the 4, you will get 25 by 4, which is something like 6.25 meters per second square. But I want the T, I want the tension. But see, once you have calculated this, it is easy to find the tension. So what is the tension? 6 into A. 6 into 100 by 16. I can put 6.25, 25 by 4, but you can calculate. So I'm not worried right now about the calculation, but you can see that you have calculated. What we have found is this tension and we have found that tension. So I hope this is clear. So whenever we deal with a pulley, we are going to right now focus only on smooth massless pulleys and massless ropes. So we're making a lot of assumption. We are saying smooth massless pulley, massless rope, then this tension is equal to this tension is equal to this tension is equal to the tension on the other side of the pulley. So later when we see that there is an object like this, one rope, one tension. So if around this rope, around this pulley I have a rope, this side the tension is 17 newtons or 7 newtons, let's say. On that side the tension will be 7 newtons. But here the tension will not be 7 newtons. Why not? Because this is a different rope. Okay, so I have to find the tension separately. We will worry about how to do that. But basically I want you to understand that the tension here and the tension there is the same. Now tension is a very curious, weird thing. This tension is pulling this fellow up. But tension doesn't always pull up. It is pulling this fellow up. But the same tension is pulling the pulley down. Tension pulls on both sides. So this rope is pulling this up and pulling that down. It depends on who is getting connected. Is that hopefully clear? So remember, one rope, one tension. So if I had, for example, 3 blocks and I'm pulling this fellow, this will have a tension T1 T1, 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 T1. But that's also T1? No, that is T2. T2, 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 T2. I hope that is clear. One rope, one tension for massless ropes and for smooth pulleys. So please keep that in mind. So let us apply this to a whole bunch of questions, because that will then allow us to understand the concept a lot better. Like you would have seen, even to understand this, we have done a lot of problems, but we'll have to do a lot more problems to really understand and grasp Newton's laws.